Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 185. And today is our lesson number 257. Today is our very last lesson. Today is our very last video that you're going to watch on the GMAT preparation, math preparation part. I have already solved all the data sufficiency questions. And as I speak right now, we are solving the very last problem, problem number 228. There is a problem number 229 on that page, as you can see, and problem number 230. I have already done those problems on day number 229. 229 was done on day number 254. 230 was done on day number 255. Yesterday on day number 256, we did this exact same problem 228 in the simpler version. So let's take a look at it. It says, right triangle, you must have the book in front of you. Turn to the book and read the problem with me. Right triangle PQR is to be constructed in the XY plane so that the right angle is at point P. The right angle must be at point P. The line PR is to be parallel to x-axis. Line PR has to be parallel to x-axis. X and y coordinates of P, Q and R are to be integers. X and y coordinates of points P, Q and R must be whole numbers. We are told that the x and y coordinates of P, Q are to be integers that satisfy the inequality. And we are told that the x coordinate of point P, Q and R has to be somewhere between -4 and a +5. So today we will do the real version, a more complicated version, -4 to +5. -4 to +5, as opposed to the simpler version that we did yesterday. And we are told that the y coordinate must be between 6 and 16, not 2 and 5, but 6 and 16. The question simply is, how many different triangles can one construct under these constraints? How many different triangles can be constructed? So let's start. Okay, let's start with point P. If you have not watched yesterday's video, day number 256, it is imperative, it is crucial, it is important that you watch 256 first, because this one that I'm about to do, I'm going to go a little bit faster. I'm not going to go in that much detail because we already did it. We understand the concept. I'm assuming that you understand the concept. We're just doing the full-blown version, and we're going to go at a faster pace. I'm not going to draw every single small diagram to show you every minute excruciating detail. You understand? So let's begin with point P. Let's begin with point P. The x-coordinate of point P, we are told, can be from -4 to +5. -4 to +5. How many possibilities are there? Now most people here is exactly where they're going to make their first boo-boo. They say they look at -4, they look at +5, and they say there are 9 possibilities. Don't be lazy. Take your time, take a couple of extra seconds and actually count them, physically count them. So that's what I'm going to do. -4, -3, -2, -1, and then one mustn't forget the 0, and then comes 0. And then we start again. We have to go all the way up to 5. 1, 2, 3, 4, 5. There are 10 possibilities, not 9. There are 10 possibilities. There are 10 possibilities. See, this is what I meant by going a little bit faster. Yesterday we were a little bit more elaborate and so forth. Let's talk about the y coordinate. Similarly, the y coordinate of point P can be from, we are told, from 6 to 16. From 6 to 16. How many possibilities? Again, as I said before, and I'm going to say it again bluntly, don't be lazy. Count them physically. Don't just go sit there and say, well, 6 to 16, there are 10 possibilities. Count them, for crying out loud. 6, 7, 8, 9, 10. 6, 6, 7, 8, 9, 10, and then 11, 12, 13, 14, 15, and then 16. There are 11 possibilities. 6 through 16 are 11 points, not 10. There are 11 possibilities. That tells us that point P, this implies that point P can be placed at 10 possibilities for x coordinate, 11 possibilities, it should say 11, not even. 11 possibilities for y coordinate. Therefore, point P can be placed at 110 different locations. 110 different locations. In the yesterday's version, which is still on the blackboard here, it was a very simpler version, and point P could be placed at only 20 different locations. As a matter of fact, I physically showed you every single 20 possible locations. I drew it on the blackboard, and I actually showed you in a grid system as to where the 20 points would be. Here, of course, I'm not about to show you all 110 possibilities, which is why it's important that you watch yesterday. So we already found it. Point P can be placed at 110 different locations. Let's move on to point Q. Point P can be placed at 110 different locations. Point Q can be placed at, we'll find it, and this does not apply because this is from yesterday. This does not apply. This one only goes from -1 to +3. Here we have -4 to 5, and here we have from 6 to 16. Yesterday we only did from 2 to 5. It doesn't apply anymore. Today's version, it looks like this: -4 to 5. All right. -4, 1, 2, 3, 4, -4 to 5, 1, 2, 3, 4, 5, and 6 to 16. Let's call this one, let's pretend that this is 6 right here, and let's say that this is 16. This is y equal to 6, and this is y equal to 16. So our possible locations where we can place our triangle is right here in this box. Anywhere in this box we can place the triangle. I'm going to say it one more time. Watch the yesterday's video and you will see how we place different triangles there. So that's it. Let's move on to point Q. Once we have chosen point P, that would imply, once we choose point P, for example, let me draw it here so you can see it. Let's choose a triangle. Let's pretend our triangle that we're talking about is this one right here. Right here is our triangle. Now we are told that PR has to be parallel to x-axis, so this one has to be PR, and we are told that the right angle must be at point P. So I have to call this one point P, which means this is point R, this is your right angle, and this must be point Q. So once we have chosen point P, that also implies that the x coordinate of point Q is fixed. X coordinate of point Q is fixed because PQ is parallel to y-axis. And how do we know line PQ is parallel to y-axis? Because we are told that the line PR is parallel to x-axis. We are told nothing at all about line PQ being parallel to y-axis. How do we know it's parallel to y-axis? Because of two facts. First of all, we are told that point P makes a right angle. Point P makes a right angle. And secondly, we are told that PR is parallel to x-axis. The PR is parallel to x-axis, and this has to be a right angle triangle. PQ must come straight down, hence making it parallel to y-axis. So therefore, once we choose point P, we have also chosen the x coordinate of point Q. X coordinate of point Q has already been chosen. It is fixed. The y coordinate of point Q can be at how many different locations? Well, let's find out. How many different choices do we have for y coordinates? For y coordinates, we have from 6 to 16. 6 to 16, we just said, were 11 different possibilities. We have used up one of those points for point P. One of those y coordinates has been used up for point P. Wherever the point P is, it has a y coordinates. We have used up one of them. So there are only 10 possibilities. The y coordinates of point P can be at 10 different locations. X coordinate of point, y coordinate of point Q can be at 10 different locations. X coordinate of point Q is not a matter of choice. It's been fixed automatically. As soon as we choose point P, the x coordinate of point Q is already chosen. So for Q, we have only 10 choices. Let's move on to point R. We're done with this one. Let's move on to point R. Once we have chosen point P, the y coordinate of point R is also similarly fixed. You see, point P, line PR is parallel to x-axis, which means whatever the y coordinates of P is, the y coordinate of R is also the same because of the fact that they're parallel. Therefore, once we have chosen point P, we have also chosen the y coordinate. The y coordinate of R is also fixed. Question is, how many different locations can you put the x coordinate of point R? Well, how many choices did we have for x coordinate? We had from -4 to +5. We said in the beginning, we made a note of it, that there were 10 different possibilities for x coordinate. We have used up one of those x coordinates for point P. So there are 9 possibilities. 9 possibilities. There you go, voila. That's it. That's how many different triangles we can make. That's all it is. Now, 110 times 10 times 9, 11 times 9 is 99, 11 times 9 is 99, and then we have 1 0 and another 0, 2 0, voila. That is our answer. Apparently, we can have 9,900 different triangles under these constraints. And what are the constraints? Let's enumerate them. What are the constraints? Well, the x coordinate cannot be anything outside -4 and +5. The y coordinate cannot be anything outside +6 and -16. They must be whole numbers. The line PR must be parallel to x-axis. The right angle must be at point P, and so on and so forth. That's it. Under those constraints, we can still construct apparently 9,900 different triangles. Let me just confirm that's what it is. Answer choice C says 9,900. Problem number 228. Turn the page and make sure. Yes, it's point C. It is answer choice C. Okay. That's it. I'm done. I'm officially done with the GMAT math videos. I started this thing about two months ago or so, and we started from the very first problem of data sufficiency questions and the problem solving questions. There are 230 problem solving questions in the book, as you can see there. There are 174 data sufficiency questions in the book, and we have done every single one of them. If you're looking for any particular questions, you can search by page number, or you can actually search by the question number. For example, if you're looking for data sufficiency questions number 74, just type in GMAT. DS for data sufficiency, 74 without spaces, and my name. And put in my name, Keshwani. And it will pop right up. Even if you try it without my name, I'm fairly certain that you'll be able to find it. Okay, just put in GMAT DS74 and it will pop right up. Do you understand? And PS obviously for problem solving. Good luck to you on the exam, on the test. Good luck to you in your career, in your life, and it was a pleasure. If you need more help, and if you're looking to hire a tutor to help you with the math preparation of the GMAT, you can always go to my website at prep4gmat.com or simply keshwaniprep.com. Send me an email and I'll see what I can do. Okay? Bye now. Good luck to you again.